Okay, here we are. This is the Soma Cube group identity video #1 thing to show what the piece transitions are and to help define them to make a group multiplication table for these some of the solutions. Okay, so this is what we're proposing might be Klein 4. So we have 4 solutions, and we sort of by definition say that these green pieces are always going to fit back. So we have these double Z pieces that are common to all 4 of these solutions. We can see they all have the same base structure. So what changes between these 4 solutions are these Z's. So the first action is a 90-degree twist. So if I twist this 90 degrees, or pi over 4, that'll go there. And if I twist it back 90 degrees, it'll go there, which is to say I can take this one and turn it 90 degrees. So, and I'm thinking that if we define that movement as being only restricted to pi over 4, and maybe even define what plane that's in. This would be in the XY plane, I guess. So pi over 4 to 0, or 0 to pi over 4 are the only things allowed. And the same thing down here. We have pi over 4. Pi over 4, go to 0, and we have this one. 0 to pi over 4, it can be that one. So that's that one. Then we would have, to get from here to here, we have the flip. And the flip would be a 180 in Z. That becomes this, and likewise, that becomes this. 180 flip, 180 flip. And then to get from here to here, we have a pi over 4 to 0 twist, and then a Z-axis 180. And I think those are reasonable definitions of those movements. So that explains what they are and includes my defining the movements and defining and confining the movements. Okay, here's a simpler one. This shows up in lots of solutions. It can be on the top, it can be on this side or that side. So it happens quite a few times. So this just comes up and it rotates 180 degrees. And it provides 2 solutions. I believe that's a dihedral group. Then there's this thing. This is really pretty. I think this is just gorgeous. So this is 3 solutions. This thing comes out of each one. And let's get them arranged here. So these come out. And if we take the reds out, and we would just say that this is well, that's what I'm thinking anyway. I think that the transition between each one of these is, let's see, I want to get this one to a 1. So if I flip this one up on 1, that's a Z90, and then an XY90. And I think I can do something similar here. If I drop this down like this, that was a Z90, and then an XY90. And then this one's actually on 2. Let's make sure, yeah. So it would be like that. And then to get, this would be a Z90, and I think that's an XY90. I'm not exactly sure how to define that, but I think you get the idea. And I guess everything's in there, so that'll be it.